In this lesson, we're going to look at simplifying rational expressions, and we're going to focus on rational expressions that are monomial factors. Now, let's review something from previous courses. So remember in previous courses, if you had something like, let's say, 9 divided by 15. You had 9 divided by 15, and you asked to reduce this or simplify. So remember what we did in that case when we were asked to simplify 9 divided by 15. You asked yourself, what is the largest common factor for 9 and 15? And we know it's 3, so we would say 9 divided by 3 is, so remember you divided both numerator and denominator by 3, and so you get 3 divided by 5, right? And so 9/15 reduced or simplified is 3/5. But I want you to think about it in another way. So you agree that 9 divided by 15 is the same thing as saying 3 times 3 divided by 3 times 5, right? And then you can reduce common factors as you see them. So 3 is a factor of 9. And so I can reduce this factor of 3 with this factor of 3. And so basically you're going to get something that looks like this. 3 divided by 3 is 1. 3 divided by 3 is 1. And that's about all you can reduce. And so then you would say 1 times 3 is 3. And then 1 times 5 is 5. And so you get the same answer. This is the approach you're going to take with these simplifying rational expressions that involve monomial factors. Okay? So for example, let's go ahead and simplify the following. And so let's suppose we had this one, and this is our number 1. So let's suppose we had x to the 4th divided by x squared. All right, so x to the 4th divided by x squared. So if you look at this, I have, and I know those are monomial factors. You don't see any binomials, any trinomials, anything like that. So here in the numerator, you have 4 factors of x. In the denominator, you have 2 factors of x. So if you want to think about it in terms of this idea here, I can write this as x times x times x times x, right? Because x to the 4th means x multiplied by itself 4 times. Divided by, and then x squared, I can write as x times x. And then I can use this idea here. So I'm going to go ahead and reduce the common factors. So x divided by x is 1, x divided by x is 1. So these two x's, these 2 factors of x divide out. So you're left with factors of 1s in their place. So remember, when you cross this out, some students forget what that means. So when I cross this out, that means that x divided by x is a factor of 1, x divided by x is a factor of 1, just like we did here. So remember that 9 and 15 have a factor of 3 in common. That's what that is right here. So that's that factor of 3 they have in common. So when I reduce 3, so remember that factor of 3, so 3 divided by 3 is 1, 3 divided by 3 is 1. Okay? So here, I still have a factor of x in common, so I can reduce these 2 if I want to, or these 2, or these 2. It does not matter. All right, as long as if this is a factor of x and you have another one down there, then you can reduce that as well. Now, I would caution against just crossing this out, because just crossing this out and not really thinking about what that means causes some issues at some point. So when I cross this out, what that means is that x divided by x is 1, x divided by x is 1. So I get factors of 1s in their place. And it kind of makes sense if you think about it. So you see where I had 3 divided by 3 here? So y'all agree that 3 divided by 3 is 1, right? So that means that if I think about this in terms of reducing common factors, 3 and 3, they both have 3 in common. So the numerator divided by 3 is 1. The denominator divided by 3 is 1, and 1 divided by 1 is 1. Okay? So when you have that x divided by x here, x divided by x is 1, so 1 over 1 is 1. X divided by x is 1, 1 over 1 is 1. And then what you have left is this. You have 1 times x is x squared. And then 1 times 1 is 1, so your answer is x squared. Okay? So x to the fourth divided by x squared is x squared. Now you may have remembered something in a previous course, that when you divide like bases, you subtract exponents. So remember that quotient rule? So we divide like bases, subtract exponents. So if you recall, and you could use that idea here, if you recall, when you have, remember our rule, our quotient rule for exponents, and remember our quotient rule for exponents in a previous course basically says this. If you have, let's say, b to the m power divided by b to the n power, so we divide like bases, you subtract exponents, so that becomes b to the m minus n. So if you look at what you have here, x to the fourth power divided by x to the second power, the bases are the same. The base here is x, the base here is x, so that becomes x to the fourth minus 2, so you subtract exponents. And remember, it's always the exponent of the numerator subtract the exponent of the denominator. Okay, so that becomes x squared, which is what this is. Okay, but you have to be a little bit careful with some of these problems because you also talked about negative exponents in a previous course, so that can be applied here as well. Okay, so we need to start out with this example to get you an idea what to do with some of these issues that we're going to have. All right? Okay, now look at number 2. So be a little bit careful sometimes. So let's look at this one right here. So we're going to start out, we're going to build on what we just did here. So let's suppose I had this. Let's suppose I had x to the fifth divided by, let's say, x. And then, well, let me put times, let's say, times y squared over y to the seventh. Let's say we had that. All right, now, some students can go right away and they can do the work with what they see, okay? Some of you may need to do what I'm about to do, and that's fine. So I'm going to make it look like this idea here. So in other words, see where I have factors of x up here and factors of x down there? So I'm going to rewrite this, and you don't have to. I'm going to rewrite this as x to the fifth divided by x times, and then I'm going to put the y's together, times y to the second divided by y to the seventh. Okay? And then I'm going to think about this idea here. So look at what we have in this little part here. I have 5 factors of x and then 1 factor of x here. So if I were to simplify this, to reduce this, how many factors of x would you have left? You would have 4 factors of x, right? Okay? So let's think about this. And if you need to, now I will be a little bit careful in terms of keep doing it like this, and you could have, see this right here? Let me go ahead and put that on the side. X to the fifth divided by x. Y'all agree? Y'all agree? That's going to be x times x times x times x times x divided by x. And so these x's divide out. You're left with factors of 1. And so notice what you have left. 1 times x times x times x times x is x to the fourth divided by 1, right? Which is x to the fourth. Okay, so that's what this is. So this right here is just x to the fourth. Now I'm going to write this as x to the fourth over 1 for right now. Okay? And you don't have to do this, is what I'm trying to say. You think about this. Okay, so how many factors of x do you have in the numerator? 5. How many factors of x do you have in the denominator? 1. So when I reduce them, how many factors do you have left when you simplify, when you reduce this? Well, you have 1 down here, 5 up there, so that 1, let me show you again. Okay, so that 1 divides out with one of these, and you're left with 4. All right, so and that's what most students will do. They'll get to this point where they just work it like that, and so you just get x to the fourth. Okay, and then you can do the same thing here. So the same thing here, if you think about it this way, right here, you get y squared divided by y to the seventh is y times y. Okay, and then y to the seventh, there are 7 factors of y, so you get y times y times y times y times y times y. Let me make sure I have the correct factors. 1, 2, 3, 4, 5, 6. I need one more. Times y. And then I reduce. So these y's divide out. You're left with factors of 1. Make sure you put factors of 1 in their place when you do this. These factors divide out, so you're left with 1s, and that's about it. So look at the numerator this time. So the numerator is 1 times 1, which is 1. The denominator is 1 times 1, and then times y, times y, times y, times y, times y, which is y to the 5th. And you knew you would end up with 5 factors of y, because you have 2 up here, you have 7 down here, right? And so when you reduce those, look again right here. All right, so watch what I'm doing. So when you reduce those, I'm sorry, that's supposed to be a 7. When you reduce those, you get 1 here. So y squared divided by y squared is 1. And then when you reduce these 2 factors of y with the 7 that's down here, you're left with 5 of them. So you get 1 divided by y to the 5th. All right, and that's the idea that most students want to end up dealing with. Okay, so you got to be able to understand this before you can get to this point. And so what we have is this now. Okay, so watch. You have 1 divided by, so this right here is this. So that's 1 divided by x to the 5th. And now, I'm sorry, y to the 5th, excuse me. Y to the 5th. And now I can't reduce anything else, so my answer is going to be x. Now you got to rewrite this back as one fraction. Don't leave it as a product like this. Okay, you got to write it as one rational expression. So you get x to the 4th times 1 is x to the 4th, divided by 1 times y to the 5th is y to the 5th. And that's your answer. Okay? Now you had, when we talked about this, we did quite a few things here, right? Okay, now I want to come back to our quotient rule here. So remember when we first started talking about this, we did it this way, and then we said, if you think about it, you're really just using a quotient rule, right? Okay, and so if I had used a quotient rule here, which I could have, see this right here? I could have used a quotient rule. If I want to use a quotient rule, I could have. So remember the quotient rule, when you divide like bases, you subtract exponents, so this becomes y to the 2nd power minus 7, which is y to the negative 5th. But remember when you dealt with negative exponents. So if I have y to the negative 5th, remember I got to write this as 1 over y to the 5th, and that's what this is. So just be careful when you use a quotient rule and you have negative exponents. You gotta remember about that rule. So remember your rule back then in the previous course was that if you have b to the negative m, then that's 1 over b to the m. Okay? All right, now let me go back and rewrite this and show you what you at some point how you want to become efficient with this. So see, that's a lot of work we did here, right? And in your mind, that's what you're doing, okay? But you want to try and be a little bit more efficient with something like this, with these monomial factors. So at some point, you want to end up doing this. I'm going to go ahead and rewrite number 2 again. So we're going to redo number 2. So I get x to the 5th divided by x. Well, that's x to the 5th y squared divided by x y to the 7th. And so what some students, the way you want to end up doing this is this way. So you're going to say, all right, I have factors of x in the numerator, I have factors of x in the denominator, so I'm going to reduce those. So I have 1 factor of x here. Okay, so I'm going to put one in its place because x divided by x is 1. And then I have 5 up here, so I'm dividing this by 1 factor of x. I'm left with 4 of them. Okay, so I'm dividing these 2 by a factor of x. So x divided by x is 1. And so if I divide 5 factors of x by x, I'm left with 4. Over here, see where you have 2 factors of x up here and you have 7 down here? So you have more of them down there, right? You have more factors of y down there. So when you divide all these factors of y by itself, y squared divided by y squared is 1, and you divided y to the 7th by 2 factors of y, you're left with 5 of them. And so then we get x to the 4th times 1 is x to the 4th, divided by 1 times y to the 5th is y to the 5th. Okay? All right. So then if you think about this now, so if you get something that has a larger exponent, all right, if you have something that has a larger exponent, so let's say you had x to the 35th power divided by x to the, let's say, 15 times y to the 10th divided by y to the 40th, let's say. Okay? So you don't want to write out all these factors of x and all these factors of y, because you would have 35 of them that you would say x times x times x 35 times, and then the same thing for the y's, right? So you want to do that. So let's think about this. So I'm dividing factors of x up here by factors of x down here, right? So I have 35 up here, I have 15 down there, right? I have 35 in the numerator, 15 factors of x in the denominator. So what that means is that I can reduce these factors of x, and I can reduce them by dividing both of those by that smallest number you see. So x to the 15th divided by x to the 15th is 1, okay? So if I divide x to the 35th by x to the 15th, I'm left with, so all you do is just subtract 15. Remember that quotient rule? So you're left with what, 20 of them? Okay? Over here, I have 10 factors of y and then 40 factors of y. So these 10 factors of y will divide out with 10 of these. And so when these 10 factors of y divide out with 10 of these, I'm left with 30 of them. Now don't forget to put a 1 here. And so then I get x to the 20th times 1 is x to the 20th. And then 1 times y to the 30th is y to the 30th. So you want to write your answer like that. Okay? Now, really what you're doing is you're using the idea of common factors like we did here. You're also using the idea of that quotient rule, if you think about it. So if I go back here, in your mind, you have x to the 35th divided by x to the 15th. And so if I use the quotient rule, when you divide like bases to subtract exponents, that's x to the 35th subtract 15, which is x to the 20th power. All right, which is what we had here. So that's x to the 20th divided by 1. For that one, for the y's, we had y to the 10th divided by y to the 40th. Okay? And so when I divide like bases, I subtract exponents, that becomes y to the 10th subtract 40th, which is y to the negative 30th. Which we know, remember you always want to rewrite your negative exponent, so that becomes 1 over y to the 30th. And so therefore, this right here, so remember we have, so let me kind of rewrite it right here. So x to the 35th divided by x to the 15th times y to the 10th divided by y to the 30th becomes, so this right here is this, x to the 20th divided by 1, and this right here is this, divided by times 1 divided by y to the 20th, but you want to rewrite this as one fraction, so that becomes x to the 20th, and that should be, I'm sorry, that's 40 right here, so that's 30, divided by y to the 30th, okay? And so that's your answer. So you have several ways to think about this, all right? But at some point, most students do it this way, all right? So they think about it in their mind, all of this, they internalize all of this right here, all of those ideas, quotient rule, dividing out common factors, writing out all your factors, dividing them out, and at some point they are able to deal with it this way, okay, or this way. All right, let's look at number 4. So number 4, let's suppose we had this for number 4. All right, number 4, we have 35 x cubed divided by 125 x times y, okay? All right, so we're going to go ahead and internalize it the way that many students will end up doing this. All right, so I want to get you to this idea here. Okay, so if you look at the coefficients, I have a coefficient of 35 and 125, okay? So what is the largest common factor of 35 and 125? Well, you notice they're both divisible by 5, right? So let's deal with it that way. And if you can't figure out the largest, then just use a common factor. Does not matter. At some point, though, you want to reduce as much as possible. So 35 divided by 5 is 7, right? So that's going to be 7 here. And then 125 divided by 5, 125 divided by 5 is 25. All right, and so notice I can't reduce 7 and 25 any further because the largest common factor, the greatest common factor of 7 and 25 is 1. Now let's go to the x's. So I have factors of x in the numerator, I have factors of x in the denominator, so I can reduce this. I can reduce the x's. I have more up here than I do down here, right? So that means that the one that has the fewer factors, when I divide that out, I'm going to have a factor of 1 in its place. So x divided by x is 1. X cubed divided by x, I'm left with 2 of them. And then over here, if you look at the y's, I can't reduce any y's. Why can't I reduce any y's? Any factors of y? Because there are no y's, no factors of y up here. So that's it. All you got to do is rewrite your answer. So look what happens. 7 times, now you got to be careful because you have quite a few strikeouts all over the place, so be careful. 7 times x squared is 7x squared divided by 25 times 1 times y is 25y, and there's your answer. Okay, so you write it as one rational expression. Okay, number 5. Number 5, let's suppose you had x to the 4th y to the 4th divided by x to the 7th, y to the 7th. All right. So again, let's internalize all that we've learned just now. I have factors of x in the numerator. I have factors of x in the denominator. So can I reduce this? Yes, you can. All right. So you have fewer in the numerator, right? You have only 4 factors of x in the numerator. You have 7 of them down there. So that means that when I reduce this, all of these will divide by itself. So x to the 4th divided by x to the 4th is 1. And I'm going to divide all of those into these 7 factors here. So I'm left with 3 of them. Okay? So it's kind of like if you had this, x times x times x times x divided by x times x times x 7 times, right? So 1, 2, 3, 4, 5, 6, 7. So basically you're saying these x's divide out, these x's divide out, these x's divide out, these x's divide out, and you're left with 1 divided by x cubed, which is what this is. All right? Now let's think about this one. So here I have 4 factors of y, 7 factors of y, so I have factors of y in both numerator and denominator, so I can reduce. I can simplify the y's, the factors of y. I have fewer up here, okay? So that means that I'm going to divide y to the 4th by y to the 4th. So y to the 4th divided by y to the 4th is 1. And then when I reduce 4 of these 7 factors, I'm left with 3 of them. All right? And so now you just rewrite this. 1 times 1 is 1. X to the 3rd power times y to the 3rd power is x to the 3rd, y to the 3rd. Okay, number 6. Number 6, we have 24 q to the 5th r to the 6th times s divided by negative 15 q to the 6th r to the 7th times s. Okay? All right, so notice that I do have a coefficient other than 1 here. See here the coefficient was 1, so that's why I didn't talk about coefficients here. But here I have coefficients that's other than 1. So that's 24 and that's negative 15. So let's think about a common factor that goes into that both 24 and negative 15 have in common. All right, so let's say it looks like 3, right? So 24 divided by 3 is 8. And then negative 15 divided by 3 is a negative 5. And it kind of makes sense if you think about what's happening. So you see you have 24 divided by, and I'm just going to put 5 for right now instead of negative 5. I'm sorry, 15. So do y'all agree I can write 24 as 3 times 8, and I can write 15 as 3 times 5? So these 3's divide out. And so that's where I get 8 and 5. Okay? All right, now let's look at the factors of q. All right, I have factors of q in the numerator. I have factors of q in the denominator. Can I simplify? Yes, because you have factors in both numerator and denominator. I have fewer in the numerator. I have more in the denominator. So that means that if you think about this right here, I'm going to reduce all of the ones that are in the numerator. And how many were there in the numerator? There were 5 of them. Some are divided by itself. And I'm going to simplify those 5 with these 6, and so I'm left with how many? 1. Okay? Let's look at the r's. I have 6 factors of r in the numerator, 7 in the denominator. So I have fewer in the numerator. So that means that all of these 6 factors of r will become factors of 1. That's what these are right here. And 6 of these, because there are 6 here, 6 of these will become factors of 1, so you're left with 1 factor of r. Okay? And so it kind of makes sense, because look, let's write it out. I want you to think about this. You have how many factors of r in the numerator? 6. 1, 2, 3, 4, 5, 6. How many factors of r you have in the denominator? 7. 1, 2, 3, 4, 5, 6, 7. And so these r's divide out. These r's divide out. These factors of r divide out. Now remember, make sure when you cross them, a lot of students forget this. You need to put 1s there because that's what that means. These r's divide out. You're left with factors of 1. These r's divide out. You're left with factors of 1. These r's divide out. You're left with factors of 1. And that's it. So the numerator, when you multiply all these factors that you have left, and those are factors of 1, you get 1. In the denominator, 1 times itself 6 times is 1, and 1 times r is r. And so that's what this is. 1, look, 1 divided by r, 1 divided by r. Okay? Now here, you have the same number of factors of s, so those automatically divide out. And so therefore my answer is going to be 8 times 1 times 1 times 1, which is 8, divided by negative 5 times q times r times 1. So that's negative 5 qr. Okay? Now there are different ways you can write this. See how you have a positive I by negative? So I can write this as negative 8 divided by 5qr for 1, 2. Okay, just know the different ways of writing this. Or if you want to, you can put the negative instead of the negative symbol being in the denominator. You can put the numerator if you want to. It's all the same thing. Okay? All right, so that's number 6. So one of these is fine. All right, let's look at number 7. Number 7, we have, all right, number 7, we have 8 x to the 4th y divided by 16 x to the 3rd power y to the 7th. Okay? All right, so let's reduce the coefficients because they're other than 1, and I can reduce this. So they're both divisible by 8. So 8 divided by 8 is 1, and then 16 divided by 8 is 2. Now let's look at the factors of x. I have factors of x in the numerator, factors of x in the denominator. Can I simplify? Yes. I have more up here though. I have fewer down here. So that means if you think about what we did when we wrote all this out, that means that all of these will divide out, okay, into 3 of those. And then I had 4 of them. So if 3 of those divide out with 3 of those, how many are you left with? You're left with 1. So you're left with a factor of x. Over here, you have 1 factor of y in the numerator, 7 in the denominator. All right, so that will divide out, and that factor of y reduces with only 1 of these. How many are you left with? 6. And so therefore your answer is going to be 1 times x times 1, which is x, divided by 2 times 1 times y to the 6, which is 2y to the 6. Okay, so that's your answer there. Number 8, let's suppose we had negative 12 x to the 5th, y to the 3rd, z, divided by, let's say that is 11 x to the second y. Okay. All right. So if you look at the coefficients, what's the common factor here? What's the greatest common factor? Well, the only factor they have in common is 1. So I cannot reduce the coefficients. But if I look at the factors of x, I have factors of x in the numerator, factors of x in the denominator. So I can reduce those, right? So in your mind, how many factors do you have down here in the denominator? There are 2 factors of x. So I'm going to reduce all of those with 2 of these. So when I reduce 2 factors of x here and 2 factors of x here, I'm left with how many? 3. All right. Now, in your mind, make sure you understand why that's occurring, because if you think about it, remember you had 2 factors of x in the denominator, you had 5 factors of x in the numerator, and so when I said that 2 factors of x will divide into itself, and then 2 factors of x will divide into here, and you're left with 3, that means this: x divided by x divided by x is 1. So x divided by x divided by x is 1. So 2 factors of x divides here, and you're left with 3. So you get x to the third power. And so that's what you see up here. All right, for the y's, factors of y, you can reduce those because you have them both numerator and denominator. So you have fewer in the denominator. So that means that all of those will divide out with one of these. And so you're left with 1. And then I cannot I cannot simplify any z's, any factors of z's, because there aren't any in the denominator. So therefore your answer is going to be negative 12 x to the third y z, just like that, divided by 11 times 1 is 11. Okay? All right, and so you just leave your answer like that. Okay, number 9. So let's look at number 9. Number 9, let's suppose we had this. Now, we have 3a to the 5th b squared raised to the third power divided by 3a to the 15th b to the 9th. Okay? All right, now, now the reason why I put that one in there is because I want to remind you about something you learned in a previous course. Just like when we talked about the quotient rule. You learned in a previous course, and it helped us with the idea of what to do with these. So remember in a previous course when I had something like x squared to the third power. Do you remember what that means? So x squared to the third power, when we first talked about that, that means x squared times itself 3 times, right? That's what this means. And so when you multiply like bases, you add exponents. That's supposed to be 2 right here. When you multiply like bases, you add exponents. So 2 plus 2 plus 2 is 6. So this became x to the 6. But you also learned then, after discussing this, hey, I can get 6 by just multiplying these exponents, multiplying these powers. Yes, and that's called the power rule. And so when you have an exponent raised to an exponent, you multiply those exponents. So 2 times 3 is 6. So this just became x to the 6th power. And so that was that rule you learned, that power rule. And so your power rule basically said this: if you have b to the m, and that's raised to the n power, then that becomes b to the m times n. So you just multiply the exponents. Okay? And that's what we're going to use here. So what I would do in this case is get rid of this parentheses right here. Make it look like all the others we were doing. Okay? And so here, if you think about this, let me go ahead and do it right here. So 3a to the 5th b squared cubed, okay, means 3 to the third power, a to the 5th raised to the third power, right? And then b squared raised to the third power. So 3 to the third is 27, so that becomes 27 up here in the numerator. A to the 5th raised to the third becomes a to the 15th using a power rule. When you have an exponent raised to an exponent, you multiply exponents. So that's a to the 15th. And then b squared raised to the third power is b to the 6th, all divided by 3. a to the 15th, b to the 9th. Okay? All right, so that's the first thing you had to do, and you had to notice you had to use something from a previous course. Now I can reduce. So let's talk about the coefficients. So 3 and 27, they have 3 in common. So 3 divided by 3 is 1. 27 divided by 3 is 9. Look at your factors of a. I have factors of a in both numerator and denominator, and it's the same number, right? It's the same number of factors. So think about that. If I have 3 times 3 divided by 3 times 3, what is that equal to? That's equal to 1 in it, because 3 divided by 3 is 1. These divide out. You're left with 1s in their place as factors, and you get 1. And that's what this is. So a to the 15th divided by a to the 15th, they divide out. Okay? Now over here, you have factors of b in both numerator and denominator. You have fewer up here, so that means all of these will divide out. So you divide out 6 factors with 6 down here. Okay? That doesn't mean you just get rid of them. You've got to have the same number down here. So if I write a 1, that means I better have 6 down here, and I do. I have 9. So 6 of those will reduce with 6 of these, and you're left with 3 of them. And so therefore your answer is going to be 9 times 1 times 1, which is 9. The denominator, 1 times b to the third, is b to the third. Okay? All right. And so in this lesson, we looked at simplifying rational expressions that were monomial factors. So all of these are monomial factors. 8 times x to the 4th times y. Monomial factors, monomial factors, monomial factors. So that was the intent of this lesson, was to get you to this point where you can simplify rational expressions, that contain monomial factors only. Okay? All right, so that'll be the end of this lesson.